Long before pharmacology existed as a discipline, communities developed complex systems of healing based on plants, roots, minerals, and preparation methods. This was not random use of herbs. Dosage mattered, timing mattered, combination mattered. Some plants were boiled, others fermented, some were applied externally, others ingested carefully. Over generations, healers observed effects. They tracked recovery. They remembered side effects. Knowledge was refined through practice. What's notable is that many plants used traditionally were later found to contain active compounds that modern medicine now isolates and studies. Pain relief, anti-inflammatory properties, antimicrobial effects. This wasn't coincidence. It was empirical testing, conducted without written charts, but preserved through memory and teaching. And this wasn't the only area where this happened. Agriculture is often discussed as a technological achievement, but at its core, it is environmental science. Long before soil chemistry was formalized, farmers understood land behavior. They practiced crop rotation. They allowed soil to recover. They recognized which crops depleted nutrients and which restored balance. Farming was timed with rainfall cycles, not calendars. Some communities developed mixed cropping systems that reduced pests naturally. Others used organic matter to improve soil structure without knowing the chemical equations behind it. Modern agricultural science later explained why these systems worked. What's surprising is how often scientific research discovered principles that had already been in use for generations, and this pattern continues beyond the ground beneath our feet. Long before mechanical clocks, time was measured through the sky. Stars were not decoration. They were guides. Communities observed star positions to predict seasons, to prepare for planting, to plan migrations. Constellations were mapped mentally, passed down through storytelling and teaching. This knowledge allowed accurate seasonal forecasting, critical for survival. Navigation followed similar principles. Landmarks, celestial patterns, and environmental cues formed reliable systems of movement. But this knowledge didn't stay in one place. As trade expanded, ideas traveled. Observations crossed regions. Systems influenced one another. Much later, astronomy became formalized. Mathematical models explained what had already been observed. Science didn't invent the sky. It learned to describe it. Perhaps one of the most striking confirmations comes from public health. Before germ theory existed, communities practiced forms of disease control based on experience, isolation of the sick, careful handling of the deceased, specific hygiene rituals. These practices weren't rooted in fear. They were rooted in observation. Communities noticed patterns. When certain steps were followed, outbreaks slowed. When they weren't, illness spread. Some settlements structured living spaces to reduce overcrowding. Others managed waste carefully to protect water sources. Modern epidemiology later validated many of these practices. What had once been considered cultural was revealed to be functional. And that brings us to a deeper question. Knowledge does not disappear. It moves. Sometimes it is written down. Sometimes it is spoken. Sometimes it is renamed. When a system is formalized, it gains legitimacy. When it is informal, it is often overlooked. History tends to credit discovery to those who document, not always to those who first understood. This doesn't diminish modern science, it enriches it, because science is strongest when it listens to human experience. Science didn't replace ancient knowledge, it explained parts of it. What we call confirmation today is often recognition delayed. Understanding this doesn't change the future of science, but it deepens our respect for its past. If this perspective challenged you, stay curious.